Good evening, everybody. My name is Greg Summers, and I have the privilege of serving as the Provost and Vice Chancellor for Academic Affairs here at UW-Stevens Point, and it is my pleasure to welcome you for our 14th Annual University Evening. It's a real privilege to have so many people here. It's a good crowd. We are always happy to share the work of our faculty and staff, not just with a lot of our faculty and staff who are here, but we have a lot of students here and community members, and this is always a good event in that way. We usually introduce this event by saying that it's a moment to share the remarkable talents of our faculty and staff with the broader community of Central Wisconsin, but we have a special treat tonight, and you're going to get kind of the full spectrum here, because we have our faculty, staff, students, and alumni. We have an 8-person presentation panel. So you're going to get to see a really remarkable demonstration of the kind of work that goes on here on a daily basis, and the really talented folks who contribute to that in all different categories of our university. So without further ado, I'm going to turn it over to Eric Yonke, who is the interim dean of our College of Letters and Science, and he's going to introduce the program tonight.
Well, good evening, and thanks to all of you who fought through the weather to come and be a part of this. This is kind of a neat event. As Greg pointed out, I'm interim dean in the College of Letters and Science, and I'm still very much getting used to this role of doing ceremonial things like introducing groups. And the first thing I thought of when I was told I had to introduce this one is I looked at the list of people and I said, I'm not going to memorize a bunch of CVs and what their sort of accomplishments are. I'm going to let them introduce themselves to do this one. And so I really do want to say, though, that it's been a delight just to hear their stories as they've gotten ready and excited to do this event for all of us. And I'm going to hand it off to Art Stevenson to sort of begin, kick us off, get us into the program, and sort of be introducing the folks as they're coming up and doing their part of the gig. So without any further ado, I want to hand it off to Art Stevenson to get us going.
Thanks. Well, I'm glad you all came. Thank you for being here. We've got quite a few great stories to tell. I'll try to get my part done in the time that I have budgeted for myself, which might be difficult. I've got a lot of slides to show. But I want to tell you a bit about eclipses and about how we sort of conceived the trip and then planned it and then chose the teams and experiments and so on and so forth. So the first thing we want to look at is what actually makes a total solar eclipse. And the circumstances are shown here. The moon has to pass between the Earth and sun in order to cast a shadow on the Earth's surface, which makes the eclipse. And it doesn't do this every time it orbits. It usually misses. Usually the shadow might pass, for instance, south of the South Pole. The moon might be down here, and the shadow will pass this way. Or perhaps on the next lunar cycle, it might pass this way because the moon is way up here. But on August 21st, 2017, the moon shadow passed directly over America, right across mid-America. And so that was a very exciting prospect for us all. Now you can see that because of the circumstances, the relative sizes of the bodies, and the relative distances, which are quite exaggerated here. The sun is actually way off scale that way somewhere. But nevertheless, the circumstances are such that a small region of the moon shadow actually intersects the Earth. This is called the umber shadow. You have to be in that part of the shadow in order for the sun's light to be totally blocked. And so that's where totality would be. You can see that it's very small. So you can see that only a small section of the Earth is covered by it. This is why that kind of eclipse is very rare. It may be centuries, for instance, before that path of totality happens to arrive where you live in Stevens Point. I think the last total solar eclipse that actually crossed Wisconsin was in 1963, and I was too young to. Well, my parents wouldn't let me outside to see it because they were afraid I was going to look at it and, go blind or something like that. So I didn't get to see that one. And it's going to be until the year 2099 by calculations of NASA and other folks that do those kind of calculations. until the next total eclipse is visible here in Stevens Point. There's going to be one in 2099. So at any rate, suffice to say they're quite rare, and you might have to travel if you want to go see one. This is what the Umbra looks like from space, and it's only a few tens of miles wide. It might be 100 miles wide or even less than that. And it passes rapidly across the surface of the Earth from west to east generally, at least this last eclipse it was from west to east. It passes very rapidly as the moon is traveling very quickly in its orbit as it moves east. I think the shadow speed for our 2017 eclipse was around 1,800 miles per hour, and so it would have taken a fighter jet that could fly 3 times the speed of sound to keep up with it, and I think NASA did that. So anyway, some predicted eclipse paths are shown here, including our eclipse last August, and here's the one that's going to intersect Stevens Point in 2099. But again, you can see how rare they are because of the circumstances of the moon shadow being quite small. So you may have to travel to go see the eclipse. Anyway, I've been interested in astronomy since I was very little. We moved into rural Portage County when I was 9, and so I looked up and saw the stars with no light pollution for the first time. And I think a couple of years after that, I looked at my first solar eclipse, and then my grandfather used to wake me up in the morning to see lunar eclipses when he was around, and so I became an eclipse fan. And I've been very excited about going to see this one for many years. You can see where the eclipse path goes here. We realized that we would have had to travel at least 1,000 miles to go to see it, which is what we did. The greatest eclipse duration was down here in Kentucky. I looked at that and I thought, well, that might be kind of fun down there. I kind of like bluegrass music. I like banjo picking, you know. Maybe I should go down there. But we decided to go elsewhere for various reasons, which will become clear. This video, which I think I have to actually touch the computer to get to go, shows you how fast the moon shadow actually swept across America in the course of 2 or 3 hours' time. So that was a view from space of the moon shadow on August 21st passing across America. And so you can see where it went. It ended up going precisely where we decided to go eventually. And was relatively cloud-free, as you can see. There's not very many clouds, and so we got lucky there. So here's what you would see in watching a total eclipse over the course of several hours. I think the duration of it was just over 3 hours. So you can see the sun here, uneclipsed, except for a teeny little bit of the moon that's coming across it. And so gradually, in the course of about an hour and so many minutes, the moon will move further and further east, covering the sun until there's almost nothing left, just a very thin crescent here. And then all of a sudden you can see the corona, because when the sun's brilliant light is totally blocked by the moon, then and only then can you see what's called the solar atmosphere. It's the corona. It's affected by the magnetic field of the sun, and so you can see loops and streamers of particles which are excited by the heat and energy of the light and the radiation that's coming from the sun. And they give off a little bit of light, but not enough to see at any other time than during a solar eclipse from the surface of the Earth. And so it's very interesting to observe the structure of this corona, which changes on a daily basis, indeed on an hourly basis. So I concluded that we should send a group out there to at least photograph the corona and try to get a good look at it. So at any rate, the entire eclipse lasts about 3 hours. And there are my times, as a matter of fact. So these are Mountain Daylight times. 10:25 was first eclipse, first contact, and mid-eclipse occurred around 11:47, and it ended by 1:13. So that's why we called it darkness at noon. Darkness at lunchtime, pretty much, and it got dark, very dark. Darker than I thought it would, as a matter of fact. I had some trouble in the dark. I couldn't see. And so Wyoming was where the circumstances of these times were plotted for, and that's one of the locations we ended up visiting. So I think in 2013, I decided, well, okay, I could go out there alone as a tourist, or maybe take my wife. We could go out there and just camp and watch the eclipse. I wanted to go out west because the weather is typically very clear out there in late August. The dog days of August, it almost never rains at lunchtime. It rains later in the day typically in western Nebraska and eastern Wyoming. So at any rate, I brought this up with a colleague, Neil Haywood, and he is a field scientist. He likes to go out in the field and take students with him and do all kinds of work out there, all kinds of studies and research. And so he was very excited about this. This was back 4 years ago. So it took a couple of years to figure out what we wanted to do. What kind of experiments do we want to do? How much money would it cost? Would we have to buy specialized equipment? How much would travel cost? And so on. And we also figured we had to go out and investigate. We didn't want to just drive out there and squat like so many did. I mean, millions of people drove out there and just squatted and did fine. But we wanted to go out there and really check it out, check out the sites before we went. And so that's what we did. We ended up getting some funding. Thank you very, very much to the folks in Letters and Science that helped us to do that. We wouldn't have been able to do it without that funding. And we certainly wouldn't have been able to take any students out there or other faculty to help us. So we're, of course, very, very grateful for that. We got our travel expenses covered. And we found out about that last year. And then in the spring, we started to recruit people to go. And it took a while to recruit them. People are very busy. Students are very busy. Summer jobs are hard to bail out of for 5 days for an eclipse trip, but we got a great bunch of people to go. And we ironed that all out last spring. So what experiments did we do? Lots of them. We had lots of objectives and experiments. We wanted to choose things that were sort of once-in-a-lifetime experiences for our participants. We needed to precisely locate the places where we were going to do our observations. We wanted to photograph the solar corona in white light and also using specialized filters to look for enhanced features of the corona. So we bought some solar filters in red and green light and wanted to look at the sun in those wavelengths as well. We wanted to look at the edge of the shadow, which is called the graze zone, and try to determine the exact time of the passage of the moon's shadow. So we wanted to make videos of that and time it precisely from a precisely determined location. This will lead you to get the solar diameter by geometry, and the solar diameter fluctuates ever so slightly, and we wanted to try to see if we could measure it at the moment of the eclipse by doing this geometry. So more about that later. We also wanted to look at biological changes. Do bats come out when it gets dark during eclipse? Do birds go to roost? What else happens? What happens to insect behavior? And so we wanted to look at that. And of course, we were going to the west. And so why we went to the west is another story. But we wanted to introduce students to some of the culture out there, which we did. We met lots of people. We collaborated with local scientists, educational facilities, national monument personnel that we visited, and so on and so forth. So lots of objectives there. And of course, we wanted to be positive examples out there for UWSP and Wisconsin. So, all right, so why did we go out to the western country here? This region, this is a cloud map, and it shows the late afternoon cloud cover probabilities based on climate records for the United States. So we didn't like the looks of South Carolina. I mean, for all I know, they could have had a hurricane, which they didn't. Actually, they had great weather. But we thought, well, let's not go down here. It doesn't look too good. It looks like it could be cloudy or nasty. If we had a few extra days, we could have gone out to Oregon, where it was quite dry. Good thing we didn't, because it was burning. There were fires all over the place out there at that time. It would have been a disaster for us. So we ended up settling on 1,000 miles away out at the eastern Wyoming and western Nebraska border. And we decided to pick some sites out there because we had a low chance of clouds during that part of the day. And so a 1,000-mile trip, that's what we planned. That was our destination. So anyway, recon trips needed to be taken. July 2016, Neil went out there by himself, right? Neil? Yeah, by yourself, okay. In November, I went out with Neil. We both went out and looked at various sites out there and verified them, located them. In March, Neil and Nancy Stakosa were back out there checking it out. In May 2017, some students went out. Jesse John and John White went out with Neil again to precisely locate some of these places that we want to visit and look at the eclipse. So as far as winning the prize for most trips out there, I guess it comes down to Neil Haywood, 5 trips, including the solar eclipse itself. So he gets 5 stars. Oh, 4 stars plus a solar eclipse for a prize. So, and that's the place where we decided that the center line of the eclipse would be. That's where the exact center of the moon shadow pass. It's a place called JM, Wyoming. It's actually 14 miles west of JM. So that's where we decided to put our Corona observation team. So John White made 2 trips out, one for surveying and one for the eclipse. So he gets a star and a sun. And Jesse John also made 2 trips out there too. So he gets a star and a sun for 2 trips. Congratulations, guys. So later on, Jesse became the lead investigator for the North Gray Zone team as well. So more about that gray zone later. Everybody's been asking me about the gray zone. What is a gray zone? Okay, so here's where we decided to post everybody. The gray zone teams. North Gray Zone team up here in the Ogallala grasslands. There's a campsite up there, free camping on U.S. Forest Service property. And so they went up and camped out there for a couple nights. They were the only ones that had to divert from the rest of the group. The rest of us all camped in Torrington. And part of the group from Torrington went down and looked at the South Gray Zone here. So anyway, what does this map mean? This middle line here, this red line, that's where the center of the eclipse shadow goes. All right? So that's where maximum totality is, 2 minutes and 29 seconds. That's where the Corona team went. That was my team. And so we're about 14 miles west of JM. That's a gray zone, that little purple line right there. That's the very edge of the shadow right there. And so here's another gray zone on the south end. And so down there, they looked at the sun just kind of peeping through the South Pole mountains of the moon. And they had 40 seconds of totality. And then the bio team and the Girl Scouts. What Girl Scouts, you ask? So we'll tell you about the Girl Scouts in just a little while. And they were at Fort Laramie doing bio research and just having a great time looking at the eclipse, and they had 2 minutes and 20 seconds of totality there. I think the Girl Scouts brought us up to 32, didn't they? 32 strong? 35? Yeah. So more about the Girl Scouts later. Okay, so this gray zone thing, this is the biggest question I get. What is a gray zone after all? Does it have anything to do with, for instance, livestock? Is this where the cows go during the eclipse or the horses? Well, we did an experiment where we wanted to measure the exact passage of the moon shadow. We wanted to time it, and we wanted to measure the position of the edge of the shadow. And so we did it by sending people to the gray zone and videoing it through a telescope. And we're going to have some people talk extensively about how they did the experiment and exactly what it means. But the end result is to allow us to figure out the exact diameter of the sun, which is a ball of plasma, which tends to fluctuate and expand and contract slightly. So it's a way of figuring out the exact diameter of the sun at the moment of the eclipse. So what they saw at just before totality was a little sliver of the sun that's still peeking around the moon, and then a minute later, they saw these little beads appear of light. And this is when the only part of the sun that can shine through is shining through the valleys and craters and low spots on the moon. And so this dark spot right here is a mountain, and there's probably another mountain here, or high ground, low ground, high ground, low ground, high ground, low ground. And that occurs near the poles of the moon from where we were watching. And knowing a little bit about the geography of the moon, which we do around the poles. We know it very well because it's always the same during eclipses. We can actually do that calculation if we make those observations very carefully. So that's why we sent people to the grays zones. Yep. Okay. Bailey's beads, that's what they're called. All right. So here's what they saw. This is the eclipse circumstances. You guys haven't seen this slide yet, have you? Okay. Well, anyway, this shows the moon as seen from the north gray zone. It just shows the moon, and most of the sun is behind the moon. And so you just see this big black thing. But up by the top here, that's where the Bailey's beads appear, by the north pole of the moon. And you can see that they've got some high ground and low ground kind of mapped out here. And there's some low ground over here too. So the sun kind of peeks through those little valleys. And that's what they see when they see the Bailey's beads. So that's just a little bit more about Gray's zone observations. So anyway, the science teams, when we did our survey out here last November, this horse liked me, and it kept walking up to me as I was on the other side of the fence. It was very lonely. I think as you look at the background there, you can see why it's lonely. So we drove out there, and it was very happy to see us. But anyway, so our science teams, we finally got everybody on board. The North Gray Zone was Jesse John, Sarah Parker, Sam Chapman. The South Gray Zone was Liza Wernicke, Jocelyn Watson, Chetamir Janke, and Zach Gumm. And then we had a bunch of people involved with bio, geography, geology, environmentals, looking at weather, and Braden Doxtel, John White, Ray Reeser, Pat Selmer, Nancy Stakosa, Neil Haywood. And the Corona team, of course, was my team. And it had Alyssa Likeness on it and Jesse Watson. I hope Jesse's here tonight. But anyway. And then there was the Girl Scout troop. Again, we'll tell you more about the Girl Scouts, but they came in and met with us in Torrington and camped with us after a rough ride. They came in after dark. They had a hard ride, and I was playing guitar in camp and keeping them awake and stuff like that. It was rough for the Girl Scouts at times, but I think they had a ball during the eclipse. So those are our teams. I'm going to try to move quickly here so I can get some other talkers up. But anyway, this shows Jesse, who eventually became our team leader at the North Gray Zone. And he and John White are doing some surveying out there last May, I believe. Isn't that right? Last May. Yeah. So they're precisely locating the North Gray Zone spot where you did your observations, right? Yeah. Okay. Let's see them at work. Oh, let's see. This is where they camped. There's actually some trees out there. Nebraska has trees. Did you know that? Those are ponderosa pines. So this is kind of an outlier from the Rocky Mountains, and that's where they camped. They were there for 2 nights, kind of staking out their place and having little adventures before they waited for the eclipse to come in. And on eclipse day, you can see they used a telescope over here. They had it set up pointing at the sun. There was a lot of wind, so they set up the car and a tent to effectively block the wind so it wouldn't rock the telescope around so that they could take their videos. It was windy out there in the plains, hot. What was it, about 93 degrees on the day of the eclipse? Yeah, so. They had company. The local ranchers showed up. It turns out there's a ranch out there owned by the Coffey family. It's a very historic ranch and very historic, storied family. And so some of those folks were out, and they found our North Gray Zone team and came and hung out with them, kept them company. You can see the license plate there. It says Coffey. So they weren't alone. The South Gray Zone, that was down about 70 miles south, I think, of them, roughly 75 miles south of them, at the South Gray Zone location. Again, we picked areas which were very quiet. We didn't want to have a whole lot of people around, even though they sometimes showed up anyway. That's okay. 40 seconds of totality down there. We had 5 people, 6, including Neil, who was taking the picture here. So there's Liza. She was the team leader, lead investigator. Zach Gumm, who was assistant, and Braden Doxtel, Chetamir Janke, and Jocelyn Watson, alum. So 6 people down at the South Gray Zone. Some of them were taking Gray Zone data, others were taking weather and biological data. So here they are at work. They've got their telescopes set up with filters on. We've got some of these telescopes and filters over here. We'll look at those later after we do our meet and greet, I guess. They also had to set up a tent to protect themselves from the wind, because you can see it's just wide open out there in the plains. And the wind was blowing hard that day. Taking weather readings during the eclipse. All right, let's talk about the bio teams and environmental and geography teams. They had to go out and scout their areas on the days before the eclipse. We spent 5 days out there, so we had plenty of time to look around. So there's Pat Zellmer. She's out checking out the Laramie River. It was 104 that day, so we can't hold it against her for taking her shoes off and getting in for a bit. So, one thing we found at that site was that there were hundreds and hundreds of cliff swallow nests. So one question might be, well, the breeding season's over in late August, but did any birds remain? Were there late breeders? Were they going to do anything during the eclipse that might be interesting to us? Were they going to go to roost, for instance, or something else? Who knows? So that would be a good place to watch. So just some pictures of environmental sensors. We had listening devices. This is a Tascam recorder. It's just an audio recorder. And then we had a trail cam out there looking for moving wildlife. So all kinds of things to do. More recon work, biological observations taken every so many minutes. They'll tell you all about that when the time comes. My team was the Corona team, and this was our location, 14 miles west of JM, where we had 2 minutes and 29 seconds of time to watch the total eclipse. It was kind of the maximum. I actually stood where the center line of the eclipse passed, because that's where it was marked out by Neil and his crew. And so we found the stake that they'd put out there, John and Jesse. So, beautiful country. This is a picture taken during the eclipse of us, and so you can see we had company too. We had lots of friends out there. That's me, that's Alyssa, and Jesse's taking the picture, and you can see our gear. We had trouble with the wind too, and we were using computers to photograph the eclipse, and so we need to see those screens. And if you've ever tried to use a computer in the sun, a laptop in the sun, you can't see it. So we had them in the vehicle and in the shade. So again, telescopes with filters. You have to filter and you have to protect your eyes during the eclipse at all times except during totality, and then off come the filters because it's safe to look at the corona. You can look at the corona, you just can't look at it at any other time. So the trip timeline was a 5-day trip. We were loaded to the gills, guitars, everything. I mean, you got to entertain yourself in camp, at those long nights. And so we left on the 18th, Friday. There were 6 vehicles. So we rented 4 cars, and we had 2 personal vehicles out there too. And so we camped in mid-Nebraska, central Nebraska one night. The next day, we ended up in Torrington at the county fair. I got in there to get my campsite. We had 2 campsites, and I got in there, and the lady goes, "Oh, we moved you." I'm like, "What? What? I drove 1,000 miles. Where did you move us?" And she's like, "Well, there's a rodeo. We had to move you just a little bit off, so that the rodeo, and oh, there's a county fair too." I'm like, "Oh, the county fair and the rodeo's in town. Whoa!" And they're here at the fairgrounds. So we moved, and we were fine. And I didn't go to the rodeo or the county fair. I just kind of hung out in camp. But the students did. They went and had a good time. It was just a short distance to walk. So, but the rest of the time we spent testing equipment. We had a little star party on Saturday night and another one on Sunday. We just had neighbors around that were camping. Everybody was there for the eclipse. I had a decent telescope, and so we all looked at Messier objects at night and tested our equipment. The next day we did the same thing, test equipment, make sure everything's working. The crew leaders were well trained. They trained all through the summer. But some of the students that were on the trip hadn't even seen the telescopes yet, and so we had to work with them. And everybody trained very quickly. We did a final visit to the eclipse locations on the day before, on the Sunday before the eclipse. And you can see it looks very different out there in the summertime. The grass is long. It's hot out. It's just beautiful country. And then one last night, and it's eclipse day. I found out that there were potentially 8-point-something million people that were going to converge on our spot. You know, I mean, if they all wanted to come out from Phoenix and Denver and, you know, so on, they could all drive up to that very same spot that we were at, and we thought it was going to be so lonesome out there. Well, so this is a picture I stole from the Wyoming DOT website. This is actually people going home after the eclipse, down I-25 back to Denver. Another lonesome little highway up there, just totally clogged with cars. It was busy enough before the eclipse, but people came up at different times. You know, they came up early to avoid the rush. But then when the eclipse was over, everybody went home at the same time. It was just crazy. So, yeah, we could have been driving up the street at that time because this is US 85 going up towards JM. You know, we would have been coming from the south towards the view here, towards me, and we would have been coming through right about that time. So this was taken by the local press. So then the next day, we just after the eclipse, we went back and camped out in mid-Nebraska and then headed home. And it took us 5 days to get out there and back and go through the whole experience. So. So I'm going to stop talking at this point. I think I've introduced enough, but some of the details are going to be covered by the people that actually did the work. You know, I'm kind of the concept guy, and I just came up with these ideas and hoped they'd work. But the people that made them work are up next, and I'd like to bring up John White next to do some talking about his part of it.
Thank you guys all for coming out. As Art said, one of our biggest challenges was location. Where did we need to be? What was best for us? And as he was pointing out, probably the best for us would have been to just go straight down southern Illinois into Kentucky. But the weather there, doing some research on that, we had about a 30% chance that there was going to be clear sky down there. Where if you went out to Nebraska and Wyoming where we did, one of the things they talked about was, that I looked up, is that there's about a 70% chance that you had a good sky. And if we talked to the locals, which we had the pleasure of seeing a lot of them, they said there's probably about a 95% chance that it was going to be a beautiful, hot day. So I think that was the biggest deciding factor for us, was just we needed to make sure we had a clear sky. Another thing Art led on about was the amount of people. The amount of people that are in this area that could have affected where we did our research was approximately maybe about 14 million total that could have come up or across or however they wanted to go. Where, as we all know, that out of in this area here, there's about 58 million people that could have come into that area to see this eclipse. So just people alone. I mean, the west, nobody's there. You get out to east of the Mississippi, and it seems like we're all here. So that was another deciding factor. And I think the third one for us was land access. There is no public land really east of the Mississippi. Everything's taken up. Down in the area where we would have possibly went, there's about 1% of that land is still public land. We're out here in Wyoming especially, almost 50% of Wyoming has public land. We could have set up almost anywhere, minus some of the ranchers. We were told several times, ranchers do lease the land, so make sure you get to know who you're dealing with and who you're talking to. So we did. This was more about their experiments that they did. But when we went out in May, Jesse and Neil and I, we scoped out all the sites. We went around, and we also had the pleasure of speaking to every county sheriff in the counties that we were going to be in. We stopped and made sure we talked to them, got to know whose land we might be invading, who we could talk to, who we needed to speak with, just so, again, we were presenting ourselves as, I guess, official as we really could. So we weren't stepping on anybody's toes, but, and you've seen in a lot of pictures, when we went out there in May, I thought we were going to be the only people out there. Jesse and I are standing in the middle of the field, and it looks like there's going to be nobody there. And when they started setting up for the eclipse, people just came from everywhere. And that was with only 15 million possible people. Now, if we would have went directly south, I think we would not have had any luck like we were hoping. So I had 2 jobs during this whole thing. As we spoke about, I went out in May to do precision measurements on where their telescopes were going to be located. We wanted to know down to a sub-meter where these telescopes were going to be so that they could take very accurate measurements. So we decided that we were going to use the Trimbles. I've had a lot of experience, fortunately, in my years here that I've worked with these. I've mapped Rib Mountain, I've mapped the Eau Claire Dells, I've mapped 9 Mile. So I've spent a lot of time working with these particular units, and they couldn't have been more valuable for what we needed to do out there as well. Sorry. And as you can see, when everything was said and done on our end, we had accuracy down to the centimeter, about a 60%, which is about a ½ an inch of where that telescope was. So these guys are able then to take that, and they know exactly where they were, so they can get as detailed of a measurement as possible. And what's great about this technology is that it just keeps getting better. Every year, every 10 years, it just keeps getting better and better. So they can get the most accurate measurements of that sun that they needed to do. My other job during the eclipse was actually really easy. I got to take weather measurements and really just enjoy the solar eclipse while I was out there. And I had the pleasure of taking my family. Neil allowed, you want to bring your family along? So I did that. I brought my son and my fiance along, and we really had a great time. But I think I enjoy doing the precision work because I just knew that this would be something bigger, so it was really nice. But for me, that was pretty much about it. I didn't do a whole ton, so I'm going to bring up Jesse and Liza now, and they're going to tell you about the solar stuff. So, thank you guys.
So Liza and I were in charge of the grays zone experiments. I was at the northern zone, and Liza was at the southern grays zone. Now, our main goal was to do shadow geometry. And as Art said, we were trying to measure the diameter of the sun, exactly. And I'm going to come back to it, but this is going to involve good old geometry from high school. So as someone who's going into teaching, this was actually really exciting for me. So as Art said, we were looking for these Bailey's beads. Now, the Bailey's beads are just those little rays of light that go through these very well-known peaks and craters in the poles of the moon. We know where these are exactly through many, many years of research. One thing I don't know if we've really said a lot is these Bailey's beads only last for seconds before they move to a new Bailey's beads or they completely disappear. So overall, the time that we really ended up caring about was, was this time going from about A minute before the eclipse, the totality, going all the way up to when we actually had totality at about 11:48, roughly. And as you can see, it's changed very quickly to the point where just a sliver disappeared. And you can see that some of these Bailey's beads as what we were talking about. Now, the northern gray zone, where I was at, we had about 26 seconds to do all of our videoing, which is very stressful because I originally thought I had about 45 seconds. I was wrong. Liza, how much time did you have at the southern grays?
I think it was 48 seconds.
I'm kind of jealous of that. And then just 45, after totality ended, we get these Bailey's beads right as the moon and the sun go out of alignment.
Now, we were only able to get those very nice images by having the correct equipment to take pictures of the sun during the eclipse. And so what we needed to use were just some small telescopes, and they needed to be able to track. Because it turns out that if you're trying to watch something like the sun in the sky, it appears to move across the sky. The sun isn't moving, right? The Earth's rotating. But the Earth rotates really quickly. And so if you want to be able to take a video of the sun over a 15-minute period, then you need it to track and stay on the sun. So we needed to have a computer telescope with tracking capability. We also needed a solar filter, and as you can see from this image, they were actually handmade, which was pretty nice. Thank you, Art. And we also needed a device that captured video. We had to be able to take video because the Bailey's beads, as we discussed, last for just a second or two of time. And so if you were trying to take a picture every time they showed up, that would be almost impossible. We needed to be able to take video. And you don't want, and the reason that we had small telescopes, I think a lot of times when you think about a telescope, you think bigger is better, but that isn't true for every situation. The size of the telescope, the aperture, the diameter is directly related to how much light it gathers. And so if you think about, an analogy is often a rain barrel. A larger rain barrel is going to collect more rain. A larger telescope is going to collect more light. But there's also a relationship between the amount of light that is collected and the resolution or the detail that you can see. So a lot of times people think bigger telescopes are better, and in most cases they can be because you can see more detail. So as if you were looking at a cluster of stars with a smaller telescope, it might just be a blurry patch. But if you had a higher power telescope that collected more light, you'd be able to see individual stars, maybe hundreds of them. But in our case, we were just looking at the sun. You don't need to be able to see very specific detail. As you increase the diameter of a telescope, you also are decreasing the field of view. And so this is looking at 30 arc minutes of sky is the moon, and the sun is the same size as the moon in our sky, and that's what we needed to be able to see. But as you have larger and larger telescopes, you're actually looking at smaller and smaller portions of sky. And if we wanted to be able to see the whole sun, we needed to have a smaller telescope. Of course, just knowing what equipment we're going to use isn't really enough. We needed to practice and plan and know that we had everything set up so that it was going to work. You don't just take what you need and show up and hope it works out. Not if you have grant money, right? Hopefully. So we had to prepare, and Jesse and I went up to the roof of the science building at least 10 times. He went up a few more times than I did to practice with the different telescopes that we were going to be using. And there are quite a few difficulties with actually even just looking at the sun through a telescope. Turns out that you can't look at the sun with just your eyes, so you definitely don't want to look at the sun through, through a telescope. And I didn't have a finder scope. I don't know if you know what a finder scope it is. It goes on the side of a telescope and helps you find what you're looking for. And we didn't have finder scopes that had the filters on them. So what we ended up having to do in order to find the sun with the telescope is to look at the shadow on the ground and move the telescope until the shadow is a circle instead of an oval shape, right? And that takes some practice. So we definitely had to practice that. But then it also turned out that the telescope that Jesse was using didn't have the sun programmed in. So we had to practice with that, and we figured out that we actually had to look up the GPS coordinates of the sun I guess not the GPS coordinates, but we had to look up the coordinates of the sun for your particular location for that particular time so that you could program it into the telescope so that it could even salute to and find the sun. So there's a little bit of problem solving that went into even just being able to see the sun in the sky. And then of course we also needed to practice aligning the sun into the telescope. Now what that means, we talked about tracking the sky so that we can actually be looking at the sun for the entire time we're taking that video. You have to have it aligned properly for it to track properly. And normally you do something called a 2-star alignment. But what stars are you going to align it to during the day? So it took a little bit of practice and problem solving, and we thought we had it figured out. We thought we did. Next.
Next slide.
Yes. We also needed to figure out what our best option was going to be for the video capability. So we said we had to take video, we couldn't just take pictures. And we had different video cameras, they're called eyepiece cameras, that you can hook up to the eyepiece of the telescope, but they also have a very small field of view. Remember we mentioned that you wanted a larger field of view so you could see the whole sun? We practiced with these smaller eyepiece cameras, and they were only showing maybe a quarter of the sun. And so these Baily's beads are only going to appear in very particular locations, so you need to be able to see the whole sun. And so we decided to just hook up our cell phones. And this picture at the top is our first attempt of taking a picture through the telescope, and I didn't have what's called a cell phone adapter where you can actually like connect the cell phone to the telescope, so it took me like 20 tries to get that picture. But then we have a cell phone adapter for the actual experiment, which was very helpful, although still frustrating. And it ended up working out very nicely. We had some very high quality videos with the smartphones. You just had to be able to get the cell phone in the correct place to be able to record your video. One more thing we had to figure out just is that we had to be able to focus lock it and exposure lock it. So we had to go out and find special apps, but it worked, is the point. We used cell phones to record video. And I think is the video next?
Yes. So next we have a really short, well, semi-short video. This is the actual video that we recorded at the Southern Grays Zone, so Liza's group. Mm-hmm. So now we got to figure out how to make it play.
I will say that it just is black for 45 seconds because we didn't take the filter off. So we're just listening at that point.
9, 11:47. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 5, 6.
So you can hear a little bit of that wind
8,
that we had that day.
9, 30, 31, 32, 33, 34, 35, 36, 37, 38, 39, 40, 41, 42, 43, 44, 45,
Oh my
46,
God.
47, 48, 49, 50, 51, 52, 53, 54, 55, 56, 57, 58, 59, 11:48. 1, 2, 3, 4, 5, 6.
That is so cool. Oh my god.
Yeah.
That's beautiful. Oh god, I can't track it anymore.
We never actually thought about having that problem until we got there.
7, 8,
What?
9.
Flash?
Oh, hey,
Don't do that.
3,
Let's take pictures if you can.
35, 36, 37, 38.
I wish I could.
39, 40, 41.
It
42,
flashed. I don't know how not to not
43,
flash.
44, 45.
Everything's red.
I didn't practice with my camera.
47,
It was
48,
flashing.
They're rising.
49, 50, 51, 52, 53, 54, 55, 56, 57,
Oh, it's coming back.
9, 11:49. 1, 2,
So you'll actually see some of those Baily's beads as they start to come back through.
5, 6, 7, 8, 9, 10,
It
10,
was just lucky that it was in there.
12, 13, 14, 15, 16, 17, 18, 19, 20, 21,
We hit 0?
22,
That is awesome.
24, 25, 26, 27, 28,
So cool.
29, 30, 31, 32, 33, 34, 35, 36, 37, 38, 39, 40, 41, 42, 43, 44, 45, 46, 47,
It's a
48,
plane.
49, 50, 51, 52, 53, 54, 55, 56,
I think so, yeah.
8, 9,
I wasn't looking.
11:50. 1, 2,
How do I turn
3,
off the flash?
4, 5. So long.
I think that's the end of the video. So before I go back into the final goal, I just want to say a few quick things about that video. You heard that counting in the background. We had to accurately count the exact time of when we were taking this video so that we could relate that information with groups from around the country who were also doing similar projects. We were originally hoping to use radios that we lost all signal the day of. And as Liza said, we're hoping to have the tracking set up on those telescopes, which worked perfectly while we were here. Not so much day of.
I don't know if you heard that beeping. That was me manually slewing so that I could keep the sun in the field. I actually turned my tracking off completely because it was jerking it and affecting the video. So I had to manually do it the whole time.
Yeah. So back to what I was going to say next was going back to that final goal, that job of what we wanted to do, which was find the diameter of the sun. I am going to unfortunately have to do a short geometry lesson, or reminder for some of you, about similar triangles. Now, we know after John, Neil and I, our work finding our locations exactly, we knew exactly where we were on the Earth. So we had this arc distance. We had to use that and the distance that we had for our shadow to find the angle of the center line to the edge of the shadow of the moon. Now, those Bailey's bees, those things that we were looking for, we know exactly where they are on the edge of the moon. We can then use the angle, those distances to those Bailey's beads, those craters, and we have this length and the angle now. We also know the diameter of the moon exactly from many, many years of research and experiments. So we can then use that along with the fact that we know the exact distance to the sun to make similar triangles in order to measure or calculate the exact diameter of the sun at that exact moment in time. As Art said, the sun is a giant ball of plasma, so it's not a solid object. It's constantly shrinking and expanding depending on the rates of reaction inside of the sun. By doing this experiment during the eclipse, we are able to exactly, to a high level of accuracy, measure the diameter of the sun at that exact moment. When we look up the diameter of the sun on, say, the internet or read it in a textbook, that's not exact. That's the average diameter of the sun. We can then connect this information with other bodies of research, which I don't know if Art's going to get into later, or I'll probably talk about it later just because I'm kind of excited about all of this stuff. But we're actually kind of still working on doing some of those calculations, but hopefully we'll have them soon. So that was, I believe that would be my last slide, so.
There's one more.
Never mind, I forgot. So both Liza and I have multiple takeaways from this experiment and from our experience with this project. Would you like to say anything first?
Some of what we already talked about. So we wanted to make sure that we were extra prepared and we had extras of everything, and we practiced so much in advance so that everything would run smoothly. And of course, there were so many problems on the day of. So the tents we both set up were to block the wind, which we actually brought tarps thinking we'd be able to set tarps up to block the wind. Of course, where we were, there was a ditch and a very high incline, and there was no way we could drive over there, so we set the tent up real quick. And it kind of worked. And then we also had issues with my telescope after everything was aligned and set up just turned off. And it turns out there was a connection problem with the cords, and it took us about 10 minutes of monkeying with it to get it to start working again. And then, so we didn't get any images until about halfway through the eclipse. But we got it to work, and then the rest of it was perfect. So I guess the moral of the story here is there's no way you can be prepared.
No.
But that's part of science. Come as prepared as you can, and then think on the fly.
Yeah, so my group also had tech problems. Like I said, we only had about 26 seconds to get video, and when the sun disappeared, we didn't realize it at the time, but my telescope stopped tracking completely. So when we were supposed to start seeing the sun reappearing, I had nothing. So I had to really, really quickly try to find the sun while I was completely blind. So that was fun. No, it was horrible. And as I said before, I'm going into teaching. And now when I have my students in high school ask me, why should I care about learning similar triangles? Why should I care about learning geometry? I can give them a real-life experience of something I did where it was necessary to know that. I now have personal experience with working with telescopes for finding optical physics that I can teach as well. This has been a great experience for me between helping write grant proposals, trying to organize people. It's worse than herding cats. And just leading groups. This has been an amazing experience for me. And I cannot imagine what I was getting myself into when I first said, yeah, I want to help with the eclipse. And then I found out all the stuff I had to do. Liza, do you have anything else?
You said it all.
So I'll show you a few Corona team photos, and we're still kind of working on how to interpret them. I think the best photos were taken in the white light, which was done all by Alyssa, who will speak to us in a moment. And some of the highlights that we got were a prominence that, whoops, I'm sorry. Let's go back here. Here we go. Okay, a prominence which appeared over the limb of the sun, which is easily visible as a tiny little red tongue of plasma here that came up. And so I kind of blew this up and put a picture of the Earth next to it to scale to show you how big the thing is. The sun's diameter is something like 109 Earths wide. And so, you know, this corona feature would have just dwarfed us and, of course, burned us to smithereens, too. But the inner corona is something that you just don't see other than at totality. It's best observed during totality, especially the fine details of the coronal streamers. And so I kind of blew this one up a bit. It's a little overexposed in the inner corona part, but the outer corona regions can be seen here and there. The streamers, the loops, magnetic loops. Some action going on over here where that's the same place that the prominence was. So there's some sheathing going on there, perhaps. In green light, I had a little trouble with the telescope. It didn't travel well. It turned out that the collimation was just slightly off, so I couldn't quite focus it the way I wanted to. But I still got some details there. This was a narrowband filter focused on the green light part of the visible spectrum, around 532 nanometers. I wish I could have gotten it a little bit narrower, but I didn't. But anyway, let's see how that compares with the white light. So The jury's still out on whether the green light filter is going to tell us any more than the white light does, but you can kind of compare the details here. It looks like there's just a little more visible here, and what I was looking at were iron ions, which occur. There's a lot of iron in the atmosphere of the sun, and it glows in green light when it deionizes, and so it tells you a little bit more than white light. It kind of resolves just a little bit more than the white light, perhaps, and tells you what's going on in the corona. This we didn't take. This was taken on the same day by a spacecraft in orbit, and it took an ultraviolet light at several different wavelengths, and so this composite image is just presented here it's this. Whoops, I'm sorry. It's the same region right here that you're seeing down here with all this action going on, which is interesting, perhaps. So these are loops of magnetic flux in the corona. So there was a lot of activity on the sun that weekend. In fact, we lost the shortwave signal, and we lost cell phone reception for a while. I don't think that was because of the sun, but the shortwave signal probably was. So at any rate, we're still kind of trying to interpret the corona photos, but we got some good ones. I've got to brag here because Alyssa took all the white light pictures, and they're just gorgeous. And I'm just going to skip through this video here for a minute. A couple of shots were taken by Jesse Watson of the shadow of the moon, and you can kind of see how dark it is aloft, and down near the horizon it's bright. Let me back up a second here. So at any rate, I'm going to post these pictures publicly so that people can see them and kind of help themselves to them and work with them if they want to. It's kind of a sharing opportunity for the science that we did. We're just going to kind of open it up to people that want to look at it a little bit closer and work with the photos themselves. But we did have a very interesting time out there, and we had lots of friends around, other astronomers and just tourists that were coming out there. And one adventure I had was a fellow had picked up a road-killed rattlesnake, and he wanted to eat it in camp that night. And I was getting to know this guy a little bit, and I told him how to clean it. It's like cleaning a trout, basically. It's the same thing. So I told him how to do it. His wife kept saying, "Watch out for the head." I had two other adventures. Before I turn things over to Alyssa here, I had two other adventures, and one of them was that I couldn't see what I was doing during totality. You know, I'd never seen a total eclipse before, and I just didn't realize how dark it was. And it was a good thing I'd calculated my exposure times in advance, and I got them right. You know, I kind of did my homework because I couldn't see my camera settings. It was too dark, and I didn't have a headlamp ready to go. So anyway, I got the camera settings right. The other thing was when we pulled up at the JM area where we had thought we had permission, there was a fellow named Del Bass that lived down the road, and he said we could park anywhere and call the ranch if you need anything. If you run out of water, call the ranch, you know. So I parked, and we got out and started unloading, and all of a sudden these two cowboys pull up, and they're like, "Hey, you're parked on the wrong side of the road here, you should move." I'm like, "Well, no, it's Del Bass's property, isn't it?" And they're like, "Nope, and the person that owns this property, when she comes along, she's going to shoot your tires out." I'm like, "Okay, all right, we'll move. Okay, thank you." Glad to oblige. So it was an adventure, a great adventure out there, and emotional content for sure for all of us. And so I'd like to bring Alyssa Likeness up to the microphone, who took all of the white light pictures, and they're just beautiful, and she did a great job in spite of having very little practice with the camera. But she has a story to tell us. So come on up, Alyssa, please.
All right, so to start my story, I'm going to have to go back a few years to when I was in my senior year of high school, and I took an astronomy course. And this astronomy course was taught by who became my favorite teacher, Mr. Todd. Now, a lot of high schools don't really offer classes in astronomy, but Mr. Todd was very adamant that this school create this course, and in many ways he is responsible for the existence of this course. And I took it just because I figured it would be an easy science credit to finish out my senior year of high school, but I did not at all expect to be fundamentally changed in my views of myself and just the universe as a whole through this course. And that's because astronomy has this effect on people. It makes you feel so small and so insignificant when you look at the scale of the universe. And, you know, we definitely are small when we compare ourselves to suns and galaxies. But Mr. Todd always emphasized that because we are part of this great universe, and because the atoms in our bodies are the same atoms that are formed in the center of stars, that fact alone should make us feel monumental. Because not only are we a part of the universe, but the universe is also a part of us. There's a Serbian proverb that I think sums up this feeling pretty well. It goes, "Be humble, for you are made of earth. Be noble, for you are made of stars." And I remember one day in class, Mr. Todd telling us a story about how when he experienced this feeling firsthand, when he viewed a total solar eclipse. And the way he described it was absolutely beautiful. A sunset, what appeared to be a sunset in every direction that you look. How it got so dark so quickly, and you could start to see planets and bright stars appear in the sky. And just how the whole experience was surreal and out of this world. So after hearing his description of that experience, I thought, oh man, okay, no matter what I do, I've got to have this experience at some point in my life. So I'm so grateful to have had the opportunity to go on this trip. Now, unfortunately, about 1 year after I graduated, Mr. Todd was diagnosed with lymphoma. And just 2 years after that, he passed away. I am regretful that I wasn't able to tell him exactly what his teaching and that class meant to me and how much of an impact it had on my life, because I would not be the same person without it. But I hope to some extent that he knew, through all my pestering him after class with my questions about various astronomical phenomena, I hope he knew that that class was important to me. And so this trip was symbolic of Mr. Todd and really that whole transition in my life. So it was really meant a lot that I could go see it. And it was good to have that shared experience with him as well. And it was just as he described it. It was surreal and awe-inspiring and really just a humbling reminder of the beauty of the universe that we live in.
So, thanks, Alyssa. Really appreciate that. I know how humans behave during this eclipse. Millions of them move around like they've lost their minds to go see it, right? How about wildlife? What do bats do? What do other mammals do? What do cattle do? That was a big question that we wanted to investigate too. So here to talk about it are Ray Reeser and Pat Zelmer.
Thank you all for coming. This is Pat Zelmer. I'm Ray Reeser. That should be pretty easy to figure out, right? So this is going to be a little bit of a departure from the astronomy side. We're going to talk a little bit about wildlife. But before we get to that, I do want to thank Art and Neil for the opportunity to be able to go on the trip. Neil had approached me about 1.5 years ago and said, hey, we're doing this great trip. We're going to go out and we're going to watch the eclipse. We're going to take students out. We're going to do some field research in Wyoming. And I thought, fabulous. I love Wyoming. I love Wyoming because it's empty. And the more I thought about it, I said, Neil, are you nuts? Wyoming's population is supposed to double for the eclipse. Still, I signed on. My background is in geology and archaeology. So I typically look at things that are seriously old and seriously dead. This was an opportunity to actually do a little wildlife research. And Pat Zelmer has been in the biology department, taught biology for 30 plus years. She's the curator of paleontology for the museum. And she also agreed to come along and keep me in line and kind of hold my hand in terms of biological research. So, technical difficulty here. There we go. So how do species react or ignore solar eclipses? Well, people have talked about this for an extremely long time, and reports of unusual animal reactions to solar eclipses date back centuries. So one of the earliest is from an Italian monk in 1239. And he noted that as the sky turned dark, all the animals and birds were terrified, and the wild beasts could easily be caught. That might just be flowery Italian prose. Obviously, something was happening, and animals and birds were having very odd reactions to what was going on during a solar eclipse. And then in 1560, astronomer Christoph Clavius wrote that during totality, stars appeared in the sky, and marvelous to behold, the birds fell down from the sky to the ground in terror of such horrid darkness. It's more likely that they went to roost, right? And then in 2001, Tora Grieve was on an expedition in Zambia, and she was actually looking at what happens with wildlife during an eclipse. And as the sun disappeared, frogs began making sounds, raptors stopped circling. These are actually things we experienced as well. And she said, giraffes started running about during the whole totality. When the sun came back, they stopped and began grazing on trees again. Well, a lot of the reports about wildlife and their reactions to eclipses are just these kind of little snippets. So in science, you like to be able to have a longer time period or a longer duration of your study so that you're monitoring wildlife before something happens, during something happening, and after something happens, so that you have really good comparisons. Well, eclipses are relatively short. They happen really quick. And during this eclipse, all around the world, people got together. They actually created apps to allow citizen scientists, to allow the public to study what's going on with wildlife, combine all of that data, and then try and figure out what was actually happening. Most of the zoos in North America did this during this eclipse. We're going to send our data to a number of other organizations that are compiling these short duration studies in order to try and figure out what sense can we make out of what's happening and what actually was going on. Again, it's a very short period of time to try and study wildlife behavior.
And if I can interject, if you took Grieve's Zambian experience and you substituted humans for giraffes, that's exactly what we saw too, only it was humans running around.
We saw absolutely, totally bizarre human behavior. So we ended up doing our biological observations on the North Platte River, a beautiful section of the river here, right next to Fort Laramie, Wyoming. And we looked at two separate locations, one on the Laramie River, and I'll pull up a map in a second, and one on the North Platte. And as Art had mentioned earlier, there were thousands of cliff swallow nests on two separate concrete bridges. And we did note a number of bird species, including both barn swallows and cliff swallows. So you see this long series of nests on the edge of the bridge. Those are cliff swallow nests. Underneath the bridge, in between the supports, are barn swallow nests. So both bird species nest on the bridge, but in very different locations. And as Art also had mentioned, by this time in August, almost all of the swallows had migrated out. There were very few swallows left. It turns out there were a number of breeding pairs that had either pulled off a second brood or bred very late and were still using the nests. It also turns out that of the 12 or so species of bats commonly seen in this area, those bats also use these swallow nests after the birds have migrated. So we did a lot of preliminary research, Pat and I did, and Neil and Art as well. We used bat recorders. We went out and monitored bat songs and calls at a number of different locations in Wisconsin. We got to where we were fairly good at recognizing different bat calls and whether bats were coming towards you or away, whether bats were honing in to prey or whether they were navigating around an object. They have very different calls and you can distinguish them. We got out to Wyoming. We never saw a bat. There was no bats came out. There were no bats at the bridges. And so the bats were a bust in terms of this study. But that's okay because we did see some cool things happen. We also had some interesting challenges because we pulled up and the park is open from sunrise to sunset. Well, what does that mean during an eclipse? Do we have to vacate? Can we stay? Park staff were really nice. So here's a map of the Fort Laramie area. You can see this circle on the bottom was the first site. This is a site that Neil and the students had gone out and looked at and thought, this looks fantastic. And in fact, it's a very scenic site. This is where Pat is standing in the river. However, at that time of year, it was virtually bereft of wildlife. There were no birds, there were very few insects. There was just nothing going on at this site. And so we decided to move up from the Laramie River about a mile to this bridge or series of bridges that cross the North Platte. And we set up between two bridges, this historic iron bridge, which was built in 1857, and a concrete bridge right next to it, which is where all the swallow nests were. And so again, like a lot of field work, you do a lot of preliminary planning. It looks like it's going to be awesome. You get out there and some aspects of it fall apart. And so one of the first things we had to do in the couple of days we had out there was to go out in the morning, go out in the evening, monitor both sites, make a judgment call on where we were going to set up. So what did we record? Well, we set up game cameras, as Art had mentioned, and we set up game cameras facing both upriver and downriver. We also set up audio recording devices to record anything that might be going on. One of the disadvantages of setting up under a highway bridge is you get a lot of highway noise, right? But we also got a lot of other recordings, especially of insects. Field notes in this case were critical. And again, this is a lesson I learned long ago. As you notice with the students recording all of their audio comments as they're watching the eclipse, seasoned field researchers no longer audio record their comments because eventually it's going to come back and bite you, right? Much better to write it in a notebook and self-edit later. In this case, John and his wife are recording atmospheric data. We had a lot of the public show up to sit on this kind of historic bridge, and we coerced them into giving us some input on what they were seeing and what they were experiencing. Pat is sitting here with a stack of books about bats, which again never showed. This is Michael Bosak, who formerly here at UWSP, he now works for the National Park Service. He's a senior science researcher for the Western region. He came out to join us and do some photography for us. Up here we have a number of game cameras that we had set up. So here's some of the field notes we took. And early in the morning, the weather was clear and sunny, wind out of the west-southwest, remained sunny throughout, no clouds visible, and this was a big deal. As John and others have noted, one of the main reasons we went to Wyoming is to get away from any potential cloud cover. The problem in late summer in the west, when it's incredibly dry and wildfires are common, is you're always taking the chance that you're going to have smoke from fires. And there were very large fires burning in Oregon and Montana. We didn't know until the day of the eclipse that we were going to have really perfect conditions, but we did. We also had set up cameras facing up and down the river. We had cameras watching the swallow nests. And in terms of what was happening with the species, we saw a lot of birds. But again, because you're only observing them for an hour or two on a given day, it's very difficult to sort out what that data means. Sure, we recorded what happened. We saw some fairly common activity, and I'll let Pat talk a little about some totally bizarre swallow activity that we saw, and we still don't know if this is common for August in Wyoming, or these are just Wyoming swallows and that's what they do, or whether this is something that was influenced by the eclipse. In total, we saw about 12 barn swallows, about 6 cliff swallows, 1 kingfisher, about 6 American crows, blue jays, sparrows, 1 unidentified duck, multiple nighthawks, 2 osprey, and 1 golden eagle. So actually, for a location where you're only there for a short period of time, that's a fair amount of bird species for an extremely dry environment like central Wyoming. Do you want to jump in and talk a little bit about the swallow activity?
Sure. And just to tell you a little bit about the raptors as well, we did see some of them. They were catching thermals, which was directly related to the heat. It was causing upward air draft. As soon as the sun went under, the temperature cooled down, the birds all settled down. So they were directly responding to the light. Insects, we think, probably were more related to temperature. The insects continued to make noise until the temperature cooled off, and then they stopped. The swallow activity was really interesting, and I'm not a bird expert by any means, but was watching the cliff swallows and barn swallows and interacting. Just before the eclipse started, there were 3 cliff swallows, so half of the population that we were watching, landed on a wire above me, and they sat completely still. They all faced east, and they never moved through the whole eclipse. In the meantime, and I was watching, clocking it every 2 minutes, a barn swallow, and I don't know if it was the same one or if it was one of a series, would fly up, fly in the face of the other 3 birds, chirp in their faces more like the sky is going to fall, you need to fly. The 3 cliff swallows never moved. The barn swallow would fly off. In 2 minutes, he would come back and nudge him again and go, "Come on, you guys, something is happening here." And they did that throughout the whole thing until it was totally dark. We weren't in complete totality, but until it got quite dark. And then they started up again as soon as the lights started back up. So I don't know if it was just a completely crazy bird that was doing that was bothering the cliff swallows. If it was a territorial thing that was going on, I'm not sure. But I had never seen a response like that to birds. So an interesting experience. The other part of it that I thought was really intriguing was that as we got there just before probably dawn, right after dawn, the human experience there, the word lunacy comes to mind, right? So we along with thousands of other people, flooded into these small communities. We completely maxed out their food source. We completely maxed out their energy. We drained all their gas tanks and everything so that we used up all the gas supplies. We clogged the roads. We used the sanitation facilities till we completely maxed those out. We went out to the bridge and we're watching. People were constantly going out to the fort until probably till just before totality, total darkness. And then as soon as the sun started to peek back out again, the traffic started going the other direction. And they caused the traffic jams that were 3 miles down the road from there. So they got that far and then they sat and waited for everybody else and their brother to move their cars. So the human behavior, which is part of the biotic community, was probably some of the most interesting that we saw.
It was interesting to see license plates from California and Connecticut and New York State pouring into the area where we were set up. And then literally, they did not wait for the eclipse to finish. As soon as totality was done, they were on the road and leaving. And I was thinking, you've driven well over 1,000 miles. Stick it out, but it didn't happen.
I think they're the same people that go to the football games and leave early when they think they know the score, right? Yeah.
So what did we find, and what does it all mean? Well, bird activity abated and then increased again with increased light and temperature levels. So you can kind of debate what happened there. Obviously light and temperature related. We had about a 10-degree temperature drop where we were. I'll let Neil talk a little bit about his research, so we were in this little protected, well-treed riverine corridor, which is unusual in central Wyoming. Neil and some of the other teams were really on open, exposed areas on the plains, and they experienced a greater temperature swing than we did. Insect activity remained fairly constant, and I say fairly because it absolutely did change. It's also very hard to distinguish certain insect calls from some frogs and especially toads. And we did hear changes, and we've got that recorded, but it's that sort of slow information to tease out of an audio recording, so we're still working on a little bit of that analysis. This was interesting. The public on the bridge, on the old iron bridge, so Pat and I were set up during the totality. We were right down at water level, recording and monitoring the cameras. The group of people who were recording up on the bridge, which is where John White and his family was, and the public was recording for us, they said, "Did you smell that? Did you smell that right at totality?" And I said, "We didn't smell anything." And they said, "It smelled like pine sol. There was this incredible pine smell right at totality." And it's hard to say what that was. It could be that occasionally when you get big temperature changes, especially along a river corridor, you can actually get changes in the way the wind or the air moves down the river corridor. And we wonder if some smell wasn't being picked up and at totality happened to funnel down the river at about 30 or 40 feet above the river. So we were right at water levels. Those guys who smelled it were 30 or 40 feet above us. Again, that's a little piece of data that's never been recorded during an eclipse before. Is it something totally cool that happens in Wyoming? Did somebody knock over a porta potty that had pine sol in it? We don't know. And that's another reason to combine all this data and really sift through it at a national level.
Before you go further, Ray, if you see the picture in the middle, that's about as dark as it got for us. It wasn't complete totality, it was like twilight. What was interesting for us, and I don't know what others experienced in other places in the country, but it was like being in the middle of a Kodachrome picture. If you remember back in the 60s and 70s, if you got a picture taken and the colors were a little wonky, that was what it looked like. The greens were almost surreal. It just had a completely tinny look to it, almost. And again, with animals like bats, where we saw nothing, heard nothing, I think the trigger that might cause them to fly at pre-dawn and at dusk didn't happen while the eclipse was taking place.
We also noted a couple of fellows came and set up on the bridge to fish during the eclipse, and I thought that was a little humorous. Also because there's big signs that say no fishing from bridge, but it's Wyoming, right? So, and I asked them what happened during totality, and they said the fish started feeding like crazy and were hitting their lures. And I think what happened was often at dusk, as light levels change, aquatic invertebrates tend to come up to the surface. And again, I'm not an aquatic biologist, but my suspicion is that something was going on with aquatic insects that triggered feeding with the fish. It was more than just light levels. So again, that might be a brand new piece of data that can be incorporated. We also saw a beaver swimming down the river, and we thought, this is great. I'm pretty familiar with beaver. I kind of know what they do. It was totally disinterested. It didn't matter, that the temperature changed or it got light or it got dark. I mean, the beaver just did not seem to care. And this is a slide that Neil Haywood compiled for us. So what he did is he took all of our biotic observations and looked at what was happening with animals and combined that with light levels and wind speed and direction and temperature at a number of locations. So Al is Fort Laramie, Neil was set up at Stegall, Nebraska, and this is what happened graphically during the eclipse. So you can see on the bottom you've got the times, and you've got the wind direction, the direction the wind was coming from on the bottom there. And then you've got the temperature. Temperatures kind of went up and where we were at Fort Laramie and then really dumped during the totality of the eclipse and then slowly climbed again. You can see at Stegall, Nebraska, they had much higher swings in temperature because they were out on the plains. Also, light levels were kind of at a plateau, really dipped as you would expect during a solar eclipse, and jumped right back up. And these are the kind of graphs that not only help us as scientists kind of put all the data together and make it meaningful, this is the kind of thing that also really helps in teaching or sharing those experiences with the public, kind of graphically pulling it together. Any more comments? So that's our piece. Again, thank you all for coming.
All right, I'm going to have to expedite a little bit. Art's going to assist me here. But you've heard a little bit about where this occurred from John and some of the early teams. You've heard also quite a bit about what occurred and why it occurred. But what I want to talk about is a little bit more human. What does it mean? Okay? You heard Alyssa speak a little bit about this. Well, it has meaning for a lot of different people. Let me just go through a few dimensions of this. And again, we are going to have to cut short a few things that we will put onto the website later. First of all, the science. Well, you've heard plenty of comment about that. Every single one of the teams had to, on-site, overcome obstacles, and they all did. Okay? Innovation was a major theme. Liza mentioned the problems with the cable connections. Well, how about just basic power? All right, Art, skip through this. All right, never mind, I got it. That's the part that goes 2 minutes and we're out of minutes. So anyway, science also entails not only the technology and astronomy in this case, but also a great deal of basic navigation. Now, I'm a geographer, so it's kind of fundamental to get to the right place at the right time without the other guys getting the ball, right? Sports and athletics has a lot of geography in it if you think about it. Well, I'm straying. Anyway, John was our principal precision surveyor with that Trimble GPS, high end, okay? But we had to know where to put ourselves. Well, we had over 30 different locations picked out that would have been suitable had we needed them, had storms forced us out or anything else. The ones we ultimately used, Art's shown you these, were Harrison on the North Gray Zone, Moore Springs, Fort Laramie itself, and Stegall, as I call it in Nebraska. Maybe it's Stegall, I don't know. Okay? Well, all right. Then we had more science, what we broadly call bioclimatology, combination of atmospherics and biologics. Okay? You've heard a little bit about the biologics and some of the atmospherics. Here's the note-taking, the instruments that we were using on site, which we will have available if you want to try them out or see them over on the sidebar after the show. These are just basic navigation GPSs. These are not the surveying precision. And then the weather device right here. All right, if you want to look at those up close, they're over on the side. Here's what one of my biggest fears was. Storms are a possibility, but we can dodge those. traffic's a possibility, and we figured out ways, even though sometimes it was slow, to get around those. But what I was concerned about was something Ray mentioned. We had major fires 1,000 miles to our west. All right, this is not from the eclipse. These are photos I took, same vantage point, 6 weeks apart 30 years ago. So they're kind of grainy, they're old. And these are the old Kodachrome slides. Anyway, this is Long's Peak from 18 miles away at Berthoud, Colorado. Okay? And this is the same telephone pole as this one. That is what California and Oregon wildfire smoke can do to your visibility. And if it's that bad horizontally, how much do you think we're going to see up there vertically? That's what one of my biggest fears was. It wasn't the only one, but this didn't materialize. The winds or the wind gods liked us. Biologics, yeah. One of the things I was looking at also was not just the wildlife, but what about also domestic plants and animals? Sunflower is a big crop out there. And you may not know it, but part of the reason it has that name is because the blossoms during the daytime generally are pointing towards the direction of the sun. I thought, before going out there and observing it, that during the eclipse, they might be shaded enough, shadowed enough, that they would close up as they do at night. They didn't do that. There's a lot of things we expected that didn't happen. The bees, the grasshoppers, the daytime insects, yes, they disappeared. The nighttime moths and insects, for the most part, the moths did not appear. Maybe it just wasn't dark long enough. Or maybe the temperature had cooled too much. We don't know for sure. But anyway, we do have the issue of things like roosters that started crowing again. They calmed way down throughout the eclipse in the morning, but they started crowing at 1 o'clock in the afternoon. Something's wrong with this picture. And there's nothing wrong with this picture. Everybody had to have safety glasses. And along with everything else, this was a trip about innovation. So this next segment is brought to you by the American Duct Tape Council. Oh. Because you take a $10 pair of binoculars, and if you're going to make them safe to view the sun, you duct tape solar filters onto them. It worked. This trip was full of innovations. You're going to see a couple more in a minute, okay? All right, well, anyway, continuing on, yes, domestic plants, animals, and pets also need safety, okay? Generally speaking, wild animals don't look at the sun. But they don't know when it goes dark that it's going to get light again very suddenly. All right. Quips and quotes of the trips. We had some memorable moments. Art mentioned a few. Here's a few more. But they all had some significance. This is not our traffic. This is what Interstate 85 in Anderson, South Carolina was posting. Because Anderson, South Carolina is a town of about 25,000 people, comparable to Stevens Point. They got 2.25 million visitors, almost all of whom drove. I know about that because my parents lived there and they were recording audios of wildlife behavior down there. We were coast to coast, okay? But anyway, the price is real. The week before we actually had the eclipse, in Torrington, Wyoming, the going rate for a single car and a single tent was $300 a night. We had 35 people in tents and 6 vehicles. Well, by doing a little bit of advance work and getting to know the locals and actually cultivating some friendship, our entire lodging bill was $210 for 4 nights, 35 people, and all of the rest. It pays to plan. We did. 4 years of it for 2.5 minutes of an eclipse. Sometimes, despite your planning, things get overlooked. This is the Last Supper before the eclipse, our style, in that campground in Torrington, Wyoming. Okay? Yeah, we forgot a few things, and the stores were sold out, so we had to improvise. Okay? You forgot the tin foil. You forgot the can opener. You forgot other stuff. There are children in the audience, right? And then you get things like this. Told you, we went out there, we got acquainted with people early, and they liked us. The sheriff of the county where the fairgrounds was kept coming back looking for us at the campground and out at Art's Corona site. Usually when you're in Wyoming and you get back to camp a little late and somebody says the sheriff was here looking for you, you get a little concerned. Not us. This guy was great. Okay? All 4 of the sheriffs we got to know were great. The national park rangers were great. The local mayor was great. You're going to see the credits here in a few minutes. Okay? But unfortunately, propriety in these days prohibits me from showing their photos. They're great people, okay? But if you're going to do something like this, get to know the locals, and they won't shoot out your tires. One of the locals was a member of a very special subpopulation, culturally, societally. And he put on also a presentation over at Agate Fossil Beds on the Sunday night before the eclipse. And he was speaking about various things, the history of his people and so on. He was telling us about what the regalia he's wearing. That's not a costume, that's demeaning. The regalia he's wearing, it weighs 120 pounds. Okay? It is 150 years old. It's heritage, what's left of it for these people. Okay? This is Kelly Looking Horse, who is an elder of the Lakota Nation. He and his wife are both elders. Well, anyway, he did get to speaking about what the eclipse means in Lakota cosmology. And among other things, this is when the ancestors return to visit. This is their window of checking up on their heritage and legacy. It's a very, very special event. And there are many, many others, not just Native American, many, many other subcultures for whom this is a spiritual and socially meaningful event. So that was another extra, not directly related to what we were doing with our telescopes and weather vanes and what have you. But we're all part of a global humanity. And you got to look at that issue of heritage from various perspectives. All right? We have a fresh alumnus, John, out there at work on the Iron Bridge. Then we have another of our teammates who was basically the site leader for a group that was at Fort Laramie, but not at the bridges. They were doing other things. And then that fellow on the right, you might recognize. That is Lieutenant Gerald R. Ford, who some of you might have heard about 30 years later. He was a Navy navigator. That is a sextant. He's observing the sun. I was a Navy navigator. I use sextants. I know what he's doing. So this isn't just a one-time, every 150 years event. But we're all contributing and leaving a legacy. Inspiration. How about those that are the next generations? Even those that are the existing or older, the elders, we can appreciate it. But what about inspiring the young? You saw Jesse and Liza, who are both going into teaching. What do you think a big part of their job's going to be? Somebody's got to run this world in 30 or 40 years, and I'll tell you, it's not going to be me. Okay? Art mentioned the Girl Scouts. I mentioned innovation. I also mentioned visibility to local folks as an institution and what have you. Well, the Girl Scouts were a smash hit. And they were an important element of what we were doing out there. They weren't technically part of the research team. The grants did not fund them. It's okay, Eric. But they came along and joined us. And they were doing things of value too. But they also got a lot of local recognition. Everybody likes a Girl Scout, probably because another month or so they start selling their cookies, right? I'm waiting for mine. They made the cover of the Torrington Times 2 days after we left. Okay? That's, whoops, hang on, back it up. That's them in living color on the cover of the local newspaper. People noticed. They also noticed who they were with. It's visibility, positive public visibility for this institution. There's a lot more people out on the Western Great Plains who have now heard of Stevens Point, many of whom have environmental or technological interests. Do the arithmetic, folks. Okay. All right. Those Girl Scouts I told you did some valuable stuff, complementing what we, with all the instrumentation and advanced degrees, were doing. This is a 13-year-old's notes. Do you suppose a 13-year-old with this kind of interest and already this kind of dedication and meticulous skills might be potential recruit material for an institution like ours? We're on their radar too. All right, the rest of this is automated. It's going to take about 3-4 minutes, and I've run way over, I apologize. But I think some acknowledgments are due, by name. These are people, note the variety of what kinds of people. These are the people who supported us. They didn't have to, but if they hadn't, this trip couldn't have gone as well as it did, despite all the speed bumps. Okay? Sheriffs, park rangers, mayors and other local politicians, private landowners, store proprietors. These are day-to-day folks. And now they know who we are. I also would like to thank Dr. Todd Good and others of the College of Letters and Science. Art did that, not only for the funding, but just the moral support and the pat on the back. We needed it. Likewise now, Dr. Yonke in his current capacity. I'd like to thank also members who helped promote us, including the editor of the local paper. He sat there observing this eclipse with us, or some of us, at Fort Laramie. Okay? So there are a number of things. And now, last introduction. As your name comes up, if you're present, with those of you on the UWSP research team, please rise and be recognized. John? Liza? Pat? Those in purple, by the way, are some of your speakers tonight. Okay? Jocelyn cannot be here. She's in La Crosse, where she works. Jesse wasn't able to be here tonight. Jesse Watson. Art Stevenson. Nance Stacosa. Ray Reeser. Chadamir Yonke. I'm sorry, Sarah Parker. Are you here? I didn't see you. Okay. Alyssa Likeness. Then Chadamir Yonke. He's in Green Bay. He also cannot be here tonight. Jesse John. Myself. Zach Gum, are you here? Don't see him. Okay. But there's one other person without whom this project wouldn't have occurred. Okay? In many ways, former Dean Christopher Sermo cheered for us the loudest and deserved quite a few himself. So that's going to have to conclude our show. I'm sorry we went 20 minutes over, but we won't do an encore tonight. All right. But we do have a few display items over along the table on the side, and we'll be over to field questions. But if Jordan, is it okay if I field a few from up here or any of our team? Jordan? Okay to field a few questions here for a few minutes? Okay. I don't know how late you want to go. Go ahead.
Is there a website or location that we can get all this stuff?
Not yet. Here, I'll hand this around. Thanks. Could I get you, sir, to repeat your question, just so the audience can hear it?
I was asking if you can provide us with a website where some of the data and the photographs would be placed.
We have a provisional one, but it's got a lot of chafe information. As Art mentioned, we will be putting together one in the future that'll be accessible. This whole presentation has been video recorded. We will be posting that on both Facebook, or YouTube is it, or Facebook, I don't know, and the university website. So you'll be able to see this again, because I know we're talking fast. Others? Okay, well, I thank you kindly.